Hi everyone, we're going to show that the series converges absolutely. We're going to use the comparison test and we'll get started by comparing it. We're going to have to do the absolute because we need to do absolute value of cosine of x to the power of n divided by n factorial plus 1. Now let's compare it to the absolute value of cosine of x to the power of n, and then just in the denominator put n factorial. Since this denominator is larger than this denominator, that means this term here is going to be larger. Now from there we can write this as less than or equal to 1 divided by n factorial, right? Because cosine is in between negative 1 and 1 for its domain. So basically, looking at this, it looks like our e to the power of x for Table-Maclaurin series, which equals the sum from n equals 0 to infinity, x to the power of n divided by n factorial. So that would be e to the x, but our x happens to be 1. So therefore, this just converges to e. All right. Now, I did another problem for you, so you might want to, this is very similar. So you might want to pause the video and try to do this one. So we're going to do the absolute value of 2 times sine of x to the power of n divided by n factorial plus 3. Now I can make this less than or equal to and pull out the 2 and take the absolute value of your x portion, sine of x to the power of n divided by n factorial. All right, and we know that sine is less than or equal to 1, absolute value of sine anyway. And so we have 2 here. So we can write this as 2 divided by n factorial. So now we have the sum from n equals 0 to infinity of 2 divided by n factorial converges to 2e. Because I can write this as 2 times 1 divided by n factorial. And this part is your e, like we discussed in the previous problem. So that's your answer. Thank you. Have a nice day. Bye-bye.